Hey, I'm Caleb with You Can Make This Too, and I think it's pretty obvious what's about to happen here, and I'm really excited about it. If you haven't caught on, this monster is going to go in this monster. We'll talk through what we're about to do because we'll just montage through getting this old one out because it's pretty simple. What I've been doing is putting fluid film on everything we got to take loose over the past few weeks to help work it loose, and then if anything gets a little stuck, I've got this LDL, JK Canvas, my buddy Will White, he told me this is the ticket to get everything loose. So pop these belts off. We're gonna reuse this piece, but I bought new bearings, so I don't have to pull out these bearings, which is gonna make this a lot easier, I think. And then just 4 bolts hold these bearings on. My dust shroud will come off, and then this heavy thing just kind of swings out of the way, and then we'll be able to lift the whole shaft out, and that's all there is to it. Then we'll set the new shaft in, put this dude on, flip it back over, put the shroud back on, and hopefully it's that easy. Invariably, something's going to happen, and I'll be talking to you. But hopefully, we'll just bust this right off, and then I'll talk to you when we're ready to put the new one on. Okay, so everything came off without a hitch. Now for the scary move, which is getting this dude in place. I think this is a fair bit heavier than that. We got another blanket, so we move to the bed, then set it up, then we'll slide the bearings on. Start bolting it. Hopefully it continues to be uneventful. Yeah, it's in. We've got a little bit of clearance everywhere, so now time to get the bearings on. And I'm going to make sure this has 2 set screws, that the set screw is up on both of them, and then I'll tighten both of these equally so that way it gets set the same in the bearings on each side. And it does look like it turns the right way, which is very key. That would have been tragic. So yeah, let's bolt these all together. Forget the last time I spoke to you. All the bearings are on and tightened. We got the tri-belt pulley on the end. Now I'm doing the tedious task of just making sure all these are snug. We actually ran into 2 or 3 that were a little loose. So pain in the butt, but I definitely don't want any of these working loose. And the wise thing as well would be, after running this for a little bit, pop the cover and check them again. But yeah, overall is uneventful. Big thing will be running some boards through it just to shimmy these bearings, shim them however we need to make sure it's coplanar or in plane with the bed, so that way I'm not making tapered boards like that, you know, that way they're the same thickness. Yeah. First time I've ever been happy to make a boring video. I think we're kind of done, so we'll close the hood and fire up just the cutter head. Safety before we run anything, just make sure everything sounds cool, but come check out how hypnotic this is. Yeah. This is where I was the first time I ever turned this machine on. Oh, that's quiet. got a piece of cherry, just jointed one side. We're gonna run it through and see what it does. And just for you, didn't put the dust shroud back on yet, so we'll try to get some shots of it coming through, see what it does. And who knows, maybe my dust collection will still do a little bit. Most likely I'm gonna be blowing cherry everywhere. That's what I do. Having a little bit of problem with getting it to cut. Problem has to do with height. It was really hard to measure that triangular cutter head, so I kind of guessed, and I was scared of it being too big and then hitting the stuff in here. The issue is with all the rollers, the cutter head is higher than the rollers are on the other one. Good thing is it's all adjustable, but we just hit the point where it tried to go through, still didn't engage the cutter head, and it hit the far side roller that holds it down, and it didn't go under it and push it. But this is all adjustable, so we just need to tweak these rollers and then we'll try again. And these stops control where the rollers normally ride. On the front one, it lifts up, and it was lifting up just fine. The problem was on this back one, it started to not lift, so we just need to help it out a little bit. So finally hit a snag. Knew something was gonna happen. At the end of the video, I'll go over the mechanics of how this whole machine works if you're curious, so stay tuned for that. But short version, this uses a conveyor belt instead of feed rollers, so all these rollers on top provide hold down pressure. Well, I didn't get a good measurement of the old cutter head because it didn't take everything apart, so this one is a little bit smaller. So if here's the in-feed roller, here was the old cutter head, whereas now with the new cutter head, here's the roller, here's the cutter head. So the stock is having to lift those cutter heads a bunch more than the machine could. I couldn't overcome the counter forces that act on those heads. But anyway, got that adjusted, and then I was running this nice wide chunky board through, and one side of this board is 20 thousandths thinner, this side, than the other side. So I did the math from the width of this board to the width of the bearings, and this bearing needs to come up about 64 thousandths, a little over 1/16 of an inch. My plan is I got some coupler nuts and I ground off the zinc coating because that's really toxic. I'm gonna weld it onto this plate and then run some bolts up, put some shims under it after I loosen this to raise it, and then tighten everything back down, do some checks. And the nice thing is I'll always have those nuts welded on there. So in the future, if I need to make any adjustments, all I gotta do is run some bolts in there, and then I can loosen this, push it how I need to, tighten things back down, which should be a whole lot better than just trying to loose it and wiggle it some and do it and hope it works through trial and error. I'd set my feeler gauges to how much I needed to move it and couldn't quite wedge it in there before the bearing maxed out on how much slop it could move. So I just pushed it all the way to the top. We're gonna see how close that is. Hopefully it's close enough. And I also went ahead and reset the set screws with Loctite. Forgot to do that the first time. So let's run it through and hopefully it's within tolerance. All right, use my handy dandy cheap calipers, and it looks like we're within a few thousandths. I'm totally happy with it. I couldn't get it any closer. And just like anything, it's one of those things where you have to understand the difference between the best work you can do and perfection, and accept the difference. Maybe someone else could dial this in a little bit better. It's the best I can dial it in. Maybe it's the best the machine can do. So whether it's my own failings or its failings, we're gonna run with it, and it's not that big a deal anyway. So yeah, next I'm gonna go over the mechanics of the machine. So if you're interested in that, stay tuned. Otherwise, thank you for watching. I hope you learned something, were inspired, or at least entertained. And until next time, make time to make something. If you're interested in learning more, we'll start back here. This is an 1890s-ish, pretty sure, machine. I bought this from a gentleman that owned a timber framing company, so he had it super souped up. Obviously, this predates like electrical motors and electric grid being a prominent thing. So this is probably ran off of a line drive. It's one of the reasons it got these big wheels. This is one of the motors I left with it. This is a 1.5 horse, 3-phase motor that drives the conveyor belt as well as the up and down mechanism for the belt. So this is my feed motor. As far as my power motor, I have this 7.5 horse 1-phase motor. It actually had a 3-phase 15 horse motor, but it's going to be super expensive to get a VFD or anything to run that. I would have had to go to a rotary phase converter, and it was going to be real expensive. So it was actually far cheaper to just replace that 15 horse with a 7.5 horse. And really, this is plenty of power for what I'm doing, because I'm not trying to put, you know, super wide beams and take heavy cuts. If I'm putting anything wide through here, at most it's, you know, maybe 2 inches thick, and I'm taking light passes anyways. So yeah, and this of course drives the cutter head. Let's look at how all the power transfers work. Of course, in the back we have the feed motor coming up here and turning this big wheel. So whenever the feed motor is turning, all this is spinning right here, and then a power transfer happens to engage the conveyor belt whenever you pull this handle. So I see we have some leverage here that's applied to these two that puts tension in the belt. Stand out of the way this time. Boom, and that tensions this belt to start driving this big wheel back here. And then you can kind of see that this big wheel has a cog with teeth on the back side of it, and it connects to this larger wheel, and this wheel is what turns a shaft that drives the conveyor belt. So here's where the final power transfer happens to turn the conveyor belt. Right in here you can actually see one of the teeth that grabs the belt and turns it. Get the shaft in there. On the other side, the other cog with another tooth. And of course that motor back there is spinning at 1750 RPM, I believe it, and we want the conveyor belt to go a lot slower than that. So we also have gear reduction along the way, because we have big to little, which is going to slow it down, and then again big to little, which is going to slow it down, and again big to little. So it's reduced quite a bit. I don't know what the actual feed rate is, hasn't done the math on it, but along the way of the power transfer, it also gears it down. The other thing that motor drives and this main shaft that's always spinning is these two pads are always turning, and then we have this dude in between that can bump off of either side, and it bumps depending on which way you pull this lever. So if I push it, it hits the close side. If I pull it, it hits the far side. Now of course both of those wheels are turning the same way, but depending on which side of that wheel in between gets engaged depends on which way this shaft is going to turn, and that controls whether it goes up or down. If I pull it, it hits the far wheel and it goes up. If I push it, it hits the near wheel and it lowers the whole bed. It does it because this shaft shoots through underneath, and then back there you can see a worm drive, I believe it's called. It takes the power going this way, and then it turns it 90 degrees into this shaft. And then we have 2 more worm drives on each end. You can see right there it's got the big screw on the end, and then that screw, same thing over here. A big worm drive driving 2 screws on each side. And from the side of the machine, here's a pretty good look at it. You can see down there is the worm screw, and it turns this screw, and as you can see, it's you know, the whole bed is resting on that. So as this big screw here, and there's another one on the other side turn, this whole bed right there, the whole bed goes up and down. And before we get to the hold downs and counterbalances, of course, between the cutter head and the motor, we just have a 3-belt linkage. There probably would have been a big belt or small belt or something here going up to a line drive originally. So our first hold down roller here, we have adjustment screws on each side that control how high it is. This is one of those things I had to mess with, because you obviously need to make sure that it's getting held down, that there's weight holding this against the conveyor belt before it hits the cutter head. Otherwise your piece is going to get shot out. But if there's too much pressure, you're not going to be able to squeeze your piece through here. So I had to raise this up, and the way the pressure is applied is that roller on both sides is connected to this linkage that goes down and then to that lever that comes out here, and it has this counterweight, one on each side, and it's on these long arms, and it has that little bolt right there you see, so you can actually slide these in and out as you need to create more or less counterweight. Of course, the farther out, the greater the leverage effect, and so you're applying more downward force on that cutter head. At the same time, when this thing bounces up, you see we have this other connecting arm and adjustment. There's a blade sort of on the front of this housing, so when this roller lifts up, it also lifts up the anti-kickback pawl, blade, whatever kind of doohickey is on this whole housing, and make sure that that's out of the way so the wood doesn't hit it. Then on the back side, we have a kind of different mechanism. This bolt and thread is the outfeed hold down roller, which of course needs to be a little bit higher than the infeed or lower than the infeed, because we'll be removing material. So whatever comes in is going to be thinner, so we need more force going down. Again, we have some stops, one on each side, that adjust the basic level of how high it is. But as far as adding tension, we just have these big springs, one on each side. And this is where I was really running into issues. Because my cutter head was higher, this outfeed roller was having to get pushed a lot higher in order for that piece to come through clearance, because it was coming through at a higher height just to get cut. And this spring I couldn't overcome the spring pressure here. So I had to take this nut down here and loosen it a bunch, because this is sort of a free-sitting spring. So it actually pushes off the housing and pushes down against this nut, which is connected to this rod. And this rod is connected to this housing. I believe it's set in there somehow. So as that force pushes down on that nut, it pulls this whole housing down. So by loosening that nut, I uncompress that spring, which lets it move up more. Tighten that nut, the spring goes into more compression, and then it won't raise as much. And I want to say that's all the mechanics of the machine. Now, as far as what I needed to do to get it going, on the right side we have two circuits, one for each, because both of these motors consume a good bit of power. So we've got the main disconnect that goes to the VFD that powers the VFD, and then we have a disconnect for the cutter head motor, the power motor, and then that powers the magnetic soft start for that motor. So that's the big soft start for the motor. And yeah, so I flip this, then I turn on the VFD, and that gets everything spinning. And then when I'm ready to engage the cutter head, get the cutter head going, I throw that lever, boom. And this also has overload protection, so this will trip if the motor starts pulling too much juice. And the other really interesting thing about this machine was actually the cutter head, which I feel is way ahead of its time, but I'm not comfortable messing with old style cutter heads like that. And setting those knives to get them parallel to the bed is a huge pain, though you do have more adjustability. So the issue I was having with getting things parallel, you could actually adjust with the blades themselves because there's enough play in it. But let me show you, it's a triangular shear cutting head. So the blades don't present in a blunt chop like most straight knives do. They were actually presented at an angle to make a shear cut, which is the advantage of having a helical blade, is then all those carbides don't blunt cut, they're offset a little bit. And so they provide a shear cut, which is a smoother cut as well, much better for figured woods and tough grain and exotics. And the way they achieve that shear cut is nifty use of this triangle. So if you follow this gullet, you can see that it's pretty deep right here. We have a really deep gullet. And by the time we get down here, it's, really smooth, not near as much of a gullet. So it was actually shifted a little bit, and that's what gives you that shear cut. Let me see if I can get an angle down here so you can kind of see it. It's really hard to tell, but if you look, you can see the difference between this line and then the blade line, and how they don't parallel each other, but they look like they're coming together towards a point. That's not just regular parallax, I believe is the word that you have. That's actually the difference in the angle. If you look at this V shape, though, how we have that gullet here and down there, it's flat. That will definitely give it away. That's how they created the shear cutting effect, which is pretty cool. Anyway, that's it. Even with having to mess with the bearings and adjust all the rollers, this was way easier than the conversion of when I put the helical on the jointer. I did a video on that. That was quite the operation. But yeah, This is such a cool piece. I'm glad you stuck around to learn some more about it. I really enjoy it. I know some people are going to wonder, so mention as far as where I got this cutter head, I reached out to a handful of companies. Only one got back to me. That company is in China, and it was from Alibaba. They quoted me $1,100, which I was really expecting to see somewhere between $5,000 and $10,000. So I jumped on it, even paid for express shipping so I wouldn't have to wait for ocean freight, which right now there's massive backlog at the ports and has been for months. So who knows how long that would have taken. And since all in, it was like $2,000, and I was expecting, you know, double to 4 or 5 times that. Seemed like a fair way to go. The quality seems really great. My only issue dealing with that company was time. You know, in theory, they're supposed to have it out the door in 15 days. Took about 2 months, but a lot of people had made that comment. But otherwise, zero issues about the quality. Happy that it's here and in and done. Well, yeah, thanks for watching. Once again, hope you learned something, were inspired, or at least entertained. And until next time, make time to make something.